I tell you, the AI copyright bots are working overtime now. I just got 3 more hits, actually, for this track used in a video. That's why I'm using it, to see if this will get a hit. I filed a dispute, and literally as soon as I hit that submit button, the claim was released. Go figure. AI, they're trying to hit us hard now. Anyway, this one, I got given a battery charger, like for a car battery, and it's not working. So let's take a look at it and see what the problem is. I was given this smart battery charger and maintainer. Just a customer at work, just when I was doing his install for him. We were talking about just general stuff, and I happened to mention that I did YouTube videos and fixed electronics. And he went over, grabbed this off of his counter, and he goes, okay, he says, you want a battery charger? It doesn't work. You can have it, okay? So let's see. He said it doesn't turn on. So let's see what it does, first of all. And does it turn on? Is there a switch on here? Switch. I guess it doesn't turn on. Good. Something to take apart and see why it doesn't turn on. Maybe it's something simple. Maybe it's beyond repair. But I do have a use for it if it does work, because it's mine now. And that is, I could use it to maintain the battery on my bike when it's parked for the winter. Like right now, it's parked for the winter. And I got a little trickle charger on there now, but this would certainly do the job a little better, because this is a battery maintainer. So let's pop this thing apart and see why it's not working. Maybe it's fixable, maybe it's not. Like I said that already. Never been into one of these before. I'm assuming it's probably got a switching power supply in here. Of course it does. Of course it's a switching power supply. Everything's a switching power supply these days. So, let's just kind of get this out of the package here so that I can at least see what's going on. All right, first things first, let's just make sure that there's nothing on the bench that this thing can short out on, because we're going to apply power to it. It doesn't have power to it now, by the way. It's disconnected. We're going to apply power and see whether we've got power getting into the inverter part of things. So, because if we don't get any power past the inverter, then nothing else is going to work. This is the AC side. This is the DC side. This will be the chopper side over here. Here's our AC going on this side. So, first things first, we'll just see, first of all, well, we can check for DC voltage. This will actually be a rectifier here. This one is probably a regulator. So, we'll check for power. And we'll just look for the voltage on this side, on the hot side. I got power on this now, so I gotta be careful. Are we getting any voltage on the AC primary side? So we should see like about 160 volts here if this thing's getting any power, and I do have 164 volts there. So we know that the rectifier on this side is working. But is the chopper working at all? Probably not. So we're going to just find the cold side on this side, which I think is probably, this is probably cold here, and we'll look at the output from the rectifier and see. Oh, we got negative 30 here. Okay. So we do have power. So what the heck? And well, it turned on this time. That display is lighting up now, and it was not lighting up before. So we must have a bad connection on here. It's got to be a bad connection. Come on. It didn't work before. You saw it. It did not light up, and now it does. Zoom the camera in real close and look for obvious bad connections, because this thing definitely did not turn on before, and it is now. So let's just take a look and see if there's any cracked connections around here. Where are we here? This is the self-resettable fuse here that I'm moving on the other side. Our AC comes in over here, and I'm a little bit too close there, I think, because the camera is having a bit of a conniption. It's not able to focus. I don't see any wires moving here, do you? See anything moving through the board? I'm looking at the same thing you guys are looking at. I'm looking at the the monitor. I should make sure that this capacitor is dead first of all before I start sticking my fingers in here, right? You know what? It might be on this plug. It might be on this plug that went to the front board, which is what controls everything. Look at some of these ones down here. Down here where my thumbnail is. How's that look? Oh yeah. Oh yeah. Look. This one right on the end here. That moves. Yeah, you can see it cracked right there. I bet you that's the fault, because this is what controls it, right? This is what turns it on and off. You switch between your different modes. Maintaining. Okay, it's a car battery, motorcycle battery, and maintaining. Let me grab a 12-volt battery. We'll see whether it actually starts to try to charge it. I do have a 12-volt battery right here. It's going to 12.3 volts. The fan just came on. 0.6, 0.7 amps. I put it onto maintaining. Yeah, I'm going to resolder that connector. That connector looks bad, and that being the one coming down from the display and the control board, I'm sure there's probably a chip on here. Let's see what's on here. I bet you there's a chip on here that communicates with the rest of the unit. I bet you there. Oh, there's a bunch of chips on here. Yeah, that would certainly do it. That would certainly do it. If you lost communication on one of those, on one of those lines, or even lost power to the display, then that circuitry is not going to work, because it definitely did not work before I took it apart. And then once I got it apart, that's when it powered up. So we know that it's got to be something relatively minor, like a solder connection. So let's just redo the one that looks like it's bad. Undo this, because that one right here, you can see how bad that one is. You can probably move it with a screwdriver. But definitely that's poor connection, and that will certainly cause the type of problem that we're having here. The old soldering iron warmed up again. Watching the hockey game. We're losing a game. Utah's beating us 1-0 in the second period. Got this going on my 20-something-year-old standard definition plasma that I use out here in the shop when I'm working. That looks a little better, for sure. Let's do the whole connector, and I'm going to do other ones that look like they might be problematic in here too, like ones on the rectifier. Everything looking good here now. Maybe we should do that chopper, as we like to call it, the switching transistor. They got the name the chopper from RCA. They used to call theirs a chopper because basically what it did is it chopped up DC into high frequency AC. Of course, RCA always did have some colorful terms for some of their components. In the old vacuum tube car radio days, the mechanical inverter was called a vibrator. And have you guys noticed the notice on the bottom of it? Did you notice the notice on the bottom? I did, but I don't know if you guys noticed it. I'll show it to you in a second here. It's a bit of a warning about what it's used for and what you don't use it for. You do not use this to charge lithium batteries. And it actually says lithium battery ban on it. What the heck? Yeah, you don't use these for charging lithium batteries unless you want to get a fire. Because it does not have protection for lithium batteries in it. It's a lead acid battery charger. Warning. Indoor use Bureau of Weight. This is there is a high pressure. The high pressure. You mean a high voltage inside. It's forbidden to charge non-rechargeable batteries. Keep the charger in good ventilation. Do not work. Put a charger in a rain or damp environment. Avoid danger of electric shock. Put it into the rain. You mean do not put it in the rain. Chargers should be placed in places where children cannot contact. Do not use charger in inflammable and explosive gas. Avoid fire. And here, this charger is only for use with lead acid batteries. Lithium battery ban. Yeah, okay. Let's power it up and see whether it turns back on, which it does. It turns on. And we're going to connect it up to a 12-volt battery. What happens if I connect it backwards? It should be smart enough to tell me that, you know, you're an idiot. You've connected your battery backwards. And it indeed does. It says, you are a dumb ass. You've hooked your battery up backwards. So don't do that. Let's put it the right way. Now what's it now going to say? 12.1 volts. And it says I'm charging. And I can select, this is a motorcycle type battery. Well, this is a security alarm battery, but maintaining, just maintain the charge. So like for example, when I put it on my bike and just leave it sit there, I leave it in maintaining mode as opposed to charging. But the guy gave me this. He says, yeah, you can have it. If you can fix it, you can have it. I fixed it. It's working. Excellent. So you got one of these things, it's not working, check for bad solder connections because, hey, they might be a dime a dozen, and when they're free, it's even better. It's always good to get stuff for free that's useful. And for me, this is useful. It's going out on my Harley. Sit there until I get the bike ready to put on the road in the spring. Even the LCD display tells me it's at 42%. It's charging. It's in slow charge. 12-volt lead acid. 13.6 volts is what we've got right now on the cell. It's charging at 2 amps. Thanks for watching. We'll catch you in the next one. Bye.